Write down photoelectric effect. What is photoelectric effect? As the name suggests, photon. Everybody knows what photons are. Photons, they fall on a surface and then electrons start moving, creating a current, which is electric. This is your photoelectric effect. Light falls on a surface, gives it some energy. Energy is absorbed by the electrons and then they start moving, developing an electric current, which is called photoelectric effect. But the way electrons absorb the energy is something which created a lot of difference in the understanding of light itself. Before this photoelectric effect was developed, the concept was developed and all, you know that from Young's, from Huygens, we established that light is a wave. Now, if light is a wave, then observations in photoelectric effect should look different as they are observed. From that, they should look different if light were a wave. Any attempt to explain photoelectric effect with the help of wave theory, wave nature of light, was not possible. Before this, it was established that with the help of diffraction, interference and all, that light is just a wave. There was a fight between the concept which Newton gave, corpuscular theory, that light is made up of particles and all, which Huygens theory proved wrong, because you know that light, when it travels in a medium, it slows down, whereas Newton's concept of corpuscular theory, that any medium particle is going to attract molecules or atoms or tiny particles of light, and if it attracts, then speed should increase. It was the concept coming from Newton. But Huygens theory proves that light is a wave, and then Young's experiments, it finally confirms the wave nature. But by the time we arrive at photoelectric effect, observations coming from this, they could not be explained by the wave nature. So let's see what those observations are, and then systematically we'll understand everything in photoelectric effect. So what basically this thing is, the setup is, this is a plate, another plate. Let's connect these plates, these two plates, with the help of an ammeter, current measuring device. Light falls on this plate, we'll call it ammeter. As light falls, electrons, they start moving in this direction. If electrons move in this direction, in this particular setup, you can see that electrons are moving that way. In this direction, there will be a current, which is photoelectric current. So this is a simple setup. That's your light. the emitter plate. This is the receiver plate. Energy is received by the electrons, they come out and then they start moving towards this plate. Electrons move this way, current travels in this direction. So this is the photoelectric setup, a very simple one. Now, what would you expect? That simple observation, and then we'll write everything point wise. Let me explain everything first. So, a normal observation would be what? If light arrives on the emitter plate and electrons are not coming out, then what would you think? You will think that let's increase the intensity of light. If we increase the intensity of light, these electrons will gain more energy and therefore they will come out. But what is found that if for a particular color, that is frequency, if for a particular color electrons are not coming out, then even if you increase its intensity, these electrons, they never come out. For example, if you have a red source of light, light falls on it, let's say a single bulb of red light, and we found that no electrons are coming out. If you switch on 20 red bulbs, even then these electrons are not coming out. Whereas wave nature, what is wave nature of light? Wave nature means the thing which you normally feel in your life, that if you increase the intensity, if you increase from 1 bulb to 20, 30 bulbs, then definitely you are going to feel more heat, more energy. And therefore, it was thought that electrons will ultimately come out if I increase the intensity. But no, it was not possible. Then what did they found? Next thing happened that from red, no electrons are coming out. But once you replace this red bulb with blue, suppose, they found that electrons, they immediately come out. The moment I change the color of light from red to blue, even when it's a very faint light, very low intensity light, electrons are coming out. As I increase the intensity, they again are coming out. Their number has increased, but then it was found that maximum kinetic energy of these electrons, that was not changing. What is maximum kinetic energy? You will understand in just a while, but just understand every profile. So with blue light, even if it's very, let's say a single ray is coming, understand this way, a single ray of blue light is coming, electrons are coming out. If I start sending 100 beams, 100 rays, again electrons are coming out. So if I increase the energy, then I would expect that electrons, they will gain more energy and therefore their kinetic energy should increase. But no, it was not happening. These electrons, they had a limited maximum kinetic energy beyond which no electron was found. Suppose electrons are maximum kinetic energy is 100 joules, then you can find electrons with 90 joule, 80 joules, but you cannot find electrons with 101 joule. Even if you increase the intensity of the blue bulb. With red, no electrons are coming out, even if I increase the number of bulbs. With blue, electrons are coming out, but if I increase the number of bulbs, then these electrons, they are still moving with same maximum kinetic energy. These are basic and important points which could not be explained with the help of wave nature of light. And one more thing, suppose at t equals to 0 you start the experiment. If at t equals to 0 we start the experiment, then wave nature tells us what? If you have a plate, metal plate, you take it under the sunlight. If you place it under the sunlight, then it becomes hot, but it takes what? Time. The moment you place it, it doesn't happen that its temperature increases. It takes a while for temperature to increase. And therefore, one would again expect that if I start sending blue light, then electrons, they should take a little bit of time so that they gain enough energy, and then only they start moving out of this emitter plate. But what is found experimentally, the moment you switch on the source of light, almost immediately these electrons are coming out. Now, what basically these points are, we'll understand in detail, but this is the overall idea which proved that there is some problem with the wave nature of light. Whatever is happening over here cannot be explained using Huygens concept, wave theory concept with photoelectrons. So, write down the points now. Observations of photoelectric effect. Observations of photoelectric effect could not be explained with the help of wave nature of light. Could not be explained with the help of wave nature of light, such as, write down observation 1. If for a given color, no photoelectric effect takes place, that means no electrons are coming out. If for a given color no photoelectric effect takes place, then even if intensity of this color is increased, photoelectric effect does not take place. That is, electrons do not come out of the emitter plate. Second observation. If for a given color photoelectric effect takes place, if for a given color photoelectric effect takes place, then even when its intensity is very low, an electric current is present in the circuit. An electric current is present in the circuit. If we increase the intensity, then this electric current increases. If we increase the intensity for this color, what is the meaning of for this color? You will also understand this part. Then electric current increases. Next observation, third. If for a given color photoelectric effect takes place, if for a given color photoelectric effect takes place, then even when its intensity is increased, even when intensity of light is increased, kinetic energy of electrons, maximum kinetic energy of electrons, do mention maximum kinetic energy of electrons does not change. Maximum kinetic energy of electrons does not change. Why is this happening? You will understand every part once we use the mathematical model for photoelectric effect. Right on the fourth observation, photoelectric effect starts the very moment source of light is switched on. Photoelectric effect starts the very moment source of light is switched on, if it has to take place. The point is, if photoelectric effect has to take place, that means if for a given color it is happening, for blue color, then the moment you switch on the light source, electrons will come out. But if for a given light it doesn't take place, but if for a given light, red light, it doesn't take place, then even if source of light is kept on, even if source of light is kept on for a very long time, no photoelectric effect is observed. No photoelectric effect is observed. See, you have seen the observations, and I've told you what is the problem with wave theory. Wave nature says that increase the number of sources, it should ultimately gain enough energy that electrons start coming out, but it's not found that way. Even if we increase the number of sources, and we keep these number of sources on for a very long time, no electrons come out, which was against the logic of wave nature of light. According to wave nature of light, energy is what? Continuous. And therefore, if this electron needs, let's say 100 joules, suppose, and energy is coming 10 joules per second. Try to understand this point. This electron needs 100 joules of energy before it comes out. But if energy is coming at the rate of 10 joules per second, then after 10 seconds, this emitter plate has enough energy. 10 joules per second. In 10 seconds, how much is the energy? 100 joules. And therefore, ultimately, this electron should come out. But no, it never comes out. If for a given color it's not coming out, whatever you can do for it, with that color, no photoelectric effect will be observed. Write down this explanation that why wave nature fails. Write down the heading, failure of wave nature of light in explaining photoelectric effect. Wave nature is very much valid with interference diffraction, but it fails to explain this. Write down the statement. According to wave nature of light, energy is continuous. According to wave nature of light, energy is continuous, and therefore, if electron needs some amount of energy, to escape the emitter plate, then either by increasing number of sources, or by increasing the time, electron should be able to absorb sufficient energy so that it can leave the emitter plate. So energy is continuous. If I say 10 joules per second, it needs 100 joules. Wait for 10 seconds, it will come out. You don't want to wait 10 joules per second, bring another source, 10 joules per second. Now there are two sources, 20 joules per second you are getting. After 5 seconds, it should come out. Increase the number of sources, eventually this electron will collect enough energy so that it can escape the emitter plate. Why does it need energy to escape the emitter plate? It's a very easy thing. Electron once starts leaving the plate, this is the plate, and as electrons start leaving the plate, remaining plate becomes what? Positively charged. Electron is coming out, remaining plate is what? Positively charged, and therefore this is Coulomb's attraction between positive plate and the negative electron. To overcome this Coulomb attraction, this electron should have enough energy. But wave nature, which tells us that energy is continuous, cannot describe everything which is happening in photoelectric effect. Now comes Einstein. Now Einstein says that light is made up of small particles, but these particles are not those particles which Newton was talking about. Newton's particles had mass. They were being attracted by the medium and all. But Einstein says the particles which light is made up of, they are basically tiny energy packets. And if they are tiny energy packets, then these energy packets are now called what? Photons. These photons, according to Einstein, are now what? Particles. Remember, as such, when you talk about a particle, you think that it will have some mass and all. These photons, they do not have any mass. They do have energy. They do have linear momentum. Remember, but they don't have any mass. So, Einstein says that light is made up of small energy packets called photons. Now, the way he explains interaction of photons with these electrons will explain everything in photoelectric effect. So now write down this Einstein's model. Write down the heading: explanation of photoelectric effect. Explanation of photoelectric effect with the help of Einstein's photon model of light. Einstein's photon model of light. Right on the first point, light is made up of small energy packets. Light is made up of small energy packets called photons. Light is made up of small energy packets called photons. Photons have no mass. Photons have no mass, but they do have energy as well as linear momentum. They are energy packets and therefore definitely they will have energy, but they do not have any mass and they definitely have some linear momentum. Second point, when a photon interacts with an electron, when a photon interacts with an electron, it is always one-to-one interaction. It is always one-to-one interaction. What is one-to-one interaction? A photon will be absorbed by one electron. This is one-to-one. A photon cannot be absorbed by two electrons simultaneously. So what is one-to-one? One electron, one photon. And then it also says that if two photons are coming, then they again cannot be absorbed by the electron. Two photons, one electron, one photon, two electron. No, that's not possible. It's always 1 to 1. Write down this in detail. That is, one electron, one photon, that is, one photon cannot be absorbed by two electrons. And similarly, two photons cannot be absorbed. Two photons cannot be absorbed by a single electron. Two photons cannot be absorbed by a single electron. It's always what? 1 to 1 interaction. How is going to help us in explaining photoelectric effect? Wait, we'll see that part. Second point. When an electron absorbs a photon, when an electron absorbs a photon, it can never absorb fraction of its energy. It can never absorb a fraction of its energy it always absorbs complete energy of the photon. It always absorbs complete energy of the photon. Let's complete the sentence and then we'll come back for it. And as long as this electron has the energy of photon in it, as long as the electron has the energy of the photon in it, it cannot interact with other photons. It cannot interact with other photons. So the point is, let's say a photon is coming with an energy of 10 joules. So partial energy absorption is something that is not allowed. If 10 joules of energy is coming and you say that, let's say, electron absorbs 2 joules and then 8 joules goes out, no, that doesn't happen. If 10 joules is coming, either it will accept 10 joules or it will not interact with the photon. It will absorb and then will re-emit the whole 10 joules. So a partial absorption, absorption of the energy is something which is not allowed. And then if it absorbs 10 joules and then starts moving, unless it removes all of this 10 joules from it, it will not interact with other photons. So it has to absorb complete 10 joules or it doesn't interact. And as long as 10 joules is present inside, it is not going to interact with other photons. Now, with the help of these basic two assumptions which Einstein tells us, we can explain everything in photoelectric effect. Light is made up of what? Small energy packets, which are what? Photons. And these photons, they have what? No mass, they have energy, they have linear momentum. Whenever interaction takes place, it's always what? One-to-one interaction. And the second thing is that partial absorption of energy is not allowed. So these are the basic main points which we are going to use in explaining everything in photoelectric effect. Now, everybody knows that energy of a photon is given by h nu. Nu is a frequency. H c upon lambda. This is the energy of a photon. Suppose we have blue color. This nu is what? Frequency of blue color. Frequency of blue color is giving us what? Energy of the photons of blue color. Those small energy packets which Einstein is talking about, their energy is what? H nu. Now, suppose this electron requires 10 joules to leave this emitter plate. Understand this way. A photon of red color, let's say its energy is 5 joules. I hope you can see red photon and energy is 5 joules. And then we have a blue photon and let's say its energy is 12 joules. Now, if I switch on a red source, red bulb, then there are billions of photons, each having what? 5 joules of energy. Billions of photons, but each having what? 5 joules of energy. This electron requires 10 joules to come out. So when this 5 joules is absorbed by the electron, 5 joules is absorbed by the electron, one-to-one interaction. Another photon will not be absorbed. You cannot say that 5 plus 5, let's absorb 2 photons. No, Einstein says no, it's always one-to-one interaction. So this electron can only receive what? 5 joules. If it receives 5 joules, then it doesn't have sufficient energy. And as long as this has 5 joule of photon inside it, it cannot interact with other photons. Which means there is no way this electron will ever achieve 10 joules of energy. Even if you keep the source on for hours. No, because interaction is what? One-to-one. It's never a partial absorption. Let's talk about the blue one. The moment this blue arrives and is absorbed by the electron, it needs 10 joules. It absorbed 12. It is going to come out. And as it comes out, 10 joules is wasted. It received what? 12. 10 is wasted to overcome that Coulomb's attraction, and then it comes out with 2 joules of energy. Remember this 2 joules of energy. If I keep intensity, if I increase the intensity of this blue source now, there are 3, 4, 5, let's say 3 photons are coming. So if 3 photons are coming or 30 photons are coming, it is going to interact with a single photon. So it always absorbs what? 12. If it absorbs 12, 10 is wasted in Coulomb's attraction, it comes out with 2. If it comes out with 2, that 2 is what? It's kinetic energy, which we say is maximum kinetic energy. Why maximum? Because when it is coming out with that 2 joules of kinetic energy, it may happen that it collides with other electrons, and during that collision, it loses part of that 2 joules of energy. So when it comes out, it is coming out with 1.5 joule. There are multiple collisions with other electrons, it loses energy, and it may happen that it completely loses all the energy, 2 joules, it doesn't come out. That may also happen, but there are billions of photons coming. Some electrons will definitely receive 12, will not encounter any collision, are going to come out clean with 2 joules of energy, but that 2 joule is the maximum. If you try to increase number of photons and you think that you have increased the intensity and therefore this electron should come out with more kinetic energy, Einstein says no, there is no way this electron can absorb 12 plus 12, 24. If it cannot absorb 2 photons, there is no way you can increase its kinetic energy. So once you introduce the concept of one-to-one interaction and no partial absorption and no interaction as long as you have the energy left inside, you explain everything which is observed in photoelectric effect. Do you understand the difference between wave nature and particle nature, and do you understand everything which I taught you so far? Yes or no? Write down fast in the comment box. If one of you is asking, do all metals show photoelectric effect? I mean, it's not about light coming in the range of waveguide. You can always increase the intensity. If electron is very tightly bound, then you can always increase the frequency. You can take it out of the visible range, waveguide, and this photoelectric effect will take place. Now, understand everything with the help of a mathematical equation. We define phi, which is called work function. What is work function? This 10 joules is work function. The tax which this electron has to pay before it comes out. So what is work function? Work function is the minimum energy an electron needs to come out of a surface. Write down this. Work function is minimum energy. Work function is minimum energy which an electron needs to overcome Coulomb's electrostatic attraction. Between itself and the emitter plate. So just let's talk about the black marker is proton and the red one is the electron. So right now they are neutral, but as this electron starts coming out, this side, this emitter thing becomes what? Positively charged, and therefore it is attracting the electron. So you need to give it sufficient energy so that it can escape all of attraction coming from the proton. So this is your phi, which is work function. You need to have this much energy. If you have to have this much energy, then this E, when you supply E energy to an electron, phi is used for the tax, and the remaining is in the form of kinetic energy. 10, this is 10, this is 12, 12 is 10 plus 2, but not always you get 2. If electron after coming out does not suffer any collision, then you will get 2. If it suffers collisions and all, you will get less than 2, and therefore this K is what K max. A very easy and elementary equation which tells you what conservation of energy. This much energy is coming, this much you have to pay as tax, and that's what you can keep with you, K max. This is the only equation which we need in this. Everything can be developed with the help of this one equation only. Now, this E is h nu. This phi is also written as h nu naught. Plus K max. You can also write in this form hc upon lambda, hc upon lambda naught plus K max. So what is nu naught? Nu naught is the minimum frequency. H nu naught corresponds to phi. So suppose you have green photon of 10 joule energy. Suppose. So this green it has 10 joules of energy. So green has 10 joules of energy, then what happens? Photoelectric effect just takes place. 10 is absorbed by the electron and just comes out. The photoelectric effect just took place. This 10 is what? Work function. Is what? Minimum frequency. Nu naught. Wavelength corresponding to minimum frequency will be maximum wavelength. Nu and lambda. Nu and lambda. This is very clear. So if nu is max, your lambda will be, nu is minimum, then your lambda will be what? Maximum. So this nu naught is minimum, but lambda naught, remember, is maximum. This nu naught is called cutoff frequency. Below the cutoff frequency, no photoelectric effect will be observed. Below nu naught, you've got 5 and there will be no photoelectric effect. So this is called what? Cutoff frequency. For photoelectric effect to take place, nu of the incident light should be greater than or equal to nu naught. Lambda of the incident light should be less than or equal to lambda naught, because lambda naught is what? Maximum. So you need to have wavelength which is under this maximum number, and for frequency you should exceed the minimum or cutoff frequency. Put on this, also this. And write down with this equation. E is the energy of incident photon. E is the energy of incident photon. Phi is work function. You already know that. Phi is work function or minimum energy required for photoelectric effect. And Ke max is the maximum kinetic energy. And Ke max is the maximum kinetic energy an electron can have in photoelectric effect. The equation is nothing but application of conservation of energy. The application is nothing but application of conservation of energy. You can also mention this, that the kinetic energy, if you talk about kinetic energy, then kinetic energy will be what? Always less than or equal to Ke max. 12, 10, 2. This is 2. But you can always have electrons moving with 1 joule of kinetic energy because it collided with some other electrons. So kinetic energy of electrons which are coming out, it will be always less than or equal to Ke max. Now, we'll understand everything with the help of some graphs and all, so that you get a visualization also. Note down everything fast. Suppose I ask you to plot a graph of Ke max and frequency of incident light. You've got 20 seconds time, draw the graph fast. The graph between Ke max and frequency of incident light. You have an emitter plate, light falls on that, you can increase or decrease the frequency of incident light, and then plot a graph between Kmax and nu. This much time is sufficient, and if you have drawn the same thing which I am going to draw, you will write yes in the comment box. So I need graph of Kmax and nu. Look here, what is Kmax? Kmax is coming h nu minus h nu naught. Kmax is y, h is m, nu is x, minus h nu naught is c. This is y equals to mx plus c, which is the equation of a straight line. M slope is positive, Planck's constant. Intercept is coming negative. If intercept is coming negative, then your graph is this. This is the graph between Kmax and nu. This portion is minus of h nu naught. If this angle is theta, then tan of theta is h. This tan theta is what? M, slope. Everybody knows about these elementary things. So you've got graph of Kmax and nu. Now, if you have drawn the same thing, write down yes in the comment box. And then notice this thing. What they found, that if they use different types of emitter plates, different materials, if different materials are present, then graphs will look like this. I hope you can see the graph. The important thing is this part, which is theta, will remain same. Why? Because for each and every graph, tan theta is what? H, which is Planck's constant and is always a constant. So what is going to change? Intercept. All the graphs will be parallel, will have same slope, but the intercept part will be different. So for a different material, if I say this is minus of phi 1, then this is minus of phi 2. Phi 1 is a work function, h nu naught minus of, but then all the graphs will be what? Parallel. So this is what was observed before Einstein explained this thing. Those who conducted experiment on photoelectric setup, they found that when they plot a graph of Kmax and nu for different materials, all the graphs were coming parallel. But Einstein explained this behavior easily with the help of what? Photon nature. Draw this graph fast. Now fast, draw the second graph. If we draw a graph of Ke max versus I, small I stands for intensity. Intensity for a given color. Write down this. Plot a graph between Ke max. Plot a graph between Ke max and intensity of light for a given color. Intensity of a given color. What I am saying is that if photoelectric effect takes place with blue color, you are increasing intensity of this blue color. That's how you are increasing intensity. Let me explain this part again. You can increase intensity in two ways. Intensity is basically what? Energy which is falling on a unit area in unit time. That's how I define intensity. Joules per second per meter square. So there are two ways you can increase the intensity. Increase number of photons. 10 joule, 10 joule, 10 joule, 10 joule. If you increase number of photons, you are getting what? More energy per unit time. You have increased the intensity. The other way is what? Send a photon of red color, then send a photon of green, then send a photon of blue. You are increasing what? Frequency. You are increasing what? Energy. You are increasing what? Intensity. What I am asking you to do in this is increase the intensity but keep the color of light same. And then if you plot a graph of K max and I, it's a very elementary and easy graph. And if you have drawn a graph like this, then write yes in the comment box. K max. If this is 10, this is 12, this is 10, then this is 2. For blue color, this is 12. Suppose if I increase the number of photons, this thing still remains what? 12 only, because it's 1-to-1 interaction, and therefore your K max is not going to change. If K max is not going to change, your graph will be this, parallel to the intensity axis. K max is not going to change if you increase the intensity for a given color. If you have drawn the same thing, then write down yours in the comment box and then you can leave. Next part of this photoelectric effect we'll discuss in the next class. Note down everything.